In this video, we'll be discussing a certain automated adding machine. Again, I'll be using the circuit illustration from the book Code by Charles Petzold. Okay, so in the previous video, we have established that modern computers are constructed with the von Neumann architecture, which the primary attribute is that instruction is also treated as code and is stored in memory. Okay, so we see here that memory contains both data and instruction. So this is primarily in RAM, stored in RAM. But in the series, in total, we have yet to define or construct the following components. First is the accumulator, then the control unit, and the input and output. Let's start off with the definition of the accumulator. An accumulator is merely a latch containing initially the first number, and then the current running total of that number, during and finally after a series of mathematical operations, plus and minus. We have built a certain accumulator with an adding machine from the previous video, but note that the only operation that the machine was able to do was add. So we were able to accumulate. We were able to construct an accumulator, but it was only for adding a set of numbers. What we are required to have for a complete computer is to do both addition and subtraction. We can say that the manual input device is being a control panel with switches that let us select the specific address on the RAM. So we have 16 toggles here, 16 switches here, and 8 switches for the number we want to store. So we also can control when to write, and finally when the input will be taking over the RAM. This allows manual entries and reading of data instruction while the operation or processing of the computer is itself automated. Right? So what happens is after we have inputted the set of numbers in the RAM, we can take our hands off the of the adding machine. It will add automatically. All right. So if it's a series of 100 numbers, it will be much easier for us to get the total of it. That's why it's an automated adding machine. It makes their job easier. Instead of every time we need an input, we enter the values one by one. In this scenario, we use the control panel to enter values into the RAM, a set of values into the RAM. For example, again, 100 numbers in total. Such control panel can be connected to the RAM through 25 2-to-1 selectors. Okay, 25 pertaining to one write switch, 16 address switches, and 8 bits of data in signals. 2-to-1 selector because the takeover switch basically can toggle between either receiving control manually from the input device or automatically from a clock counter. All right. So what this actually says that there are two sets of 25 inputs, and we can toggle between those 25 inputs by the 2-to-1 selector. We have yet to describe the circuitry of the counter, but essentially it is just a circuit that counts up one bit at a time from, let's say, 000 up until 111, for example. Okay, so here is the connection of our control panel, and as we said, it connects through to the RAM via 25 2-to-1 selectors. Of course, this pertains to a certain number of addresses. So if we have a number of addresses of 64K by 8 addresses, then 64. So what we need to consider is 64K pertains to 2 raised to 16. All right. So it's not totally 64K, but I think it's 6563. So it's 6563 times 8 addresses in total. All right. So what happens is if we open this takeover switch, all the inputs are coming an uh, from an outside source. Let's say this is coming from the set of addresses are coming from a counter. So since it's a counter, it starts with 0, 0, 0, 0. Let's say this is only 3 bits. Let's say it starts with 0, 0, 0. So therefore, the first address it pertains to the first address, and therefore it can read the first address. It can output the first address. I have to mention that the write and data in are primarily not being used uh, in in this side of the selector, because all our data will be written through our control panel. So it's only going to be used here, the write and the data in. Well, this one is being used for selecting the address only via the counter. All right. We can also say that the output device are 8 light bulbs each connected to the output of the machine. All right, as we can see here, we have eight light bulbs as data out. With these additional components, we can say that we can build a machine similar to this. All right, so this is our input. Let's say I have to mention that we have added a clear switch here, which says that which initializes our the whole of our circuitry. So the clear essentially resets the counter to 0, 0, 0H, and resets our latch to having the 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 8-bit latch to the 8-bit latches, the 8-bit latch all to 0. So essentially it's initializing everything. So this is initializing. Now we can again this the control panel is actually our input, and the light bulbs are our output. Okay, so what happens is our control panel is going to input on our RAM, which is our memory. This is our memory. So let's say it inputs, let's say it's only for 3 bits. Let's say this is only for 3 bits. So let's say it inputs, let's say we use decimal instead. So let's say the control panel inputs and the first address 1. Let's say that this is address 1, this is address 2, this is address 3. What happens is we input address 1 with a 1, and address 2 with a 2, and address 3 with a 3. So let's say value. So let's say it's the value. Value stored. Value stored. Okay, so what happens is, so after we have inputted those values using our control panel, note that our control panel connection is the one that is being used here. So this is yet to be open. Open. Well, this one is closed. 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 Or we mean that this one is the one that is receiving information. Again, this is controlled by a 25 2 to 1 selector. This is controlled by 25 2 to 1 selector. So essentially, after inputting those values into the RAM, we can use the 8-bit counter, which reads the first number, then the first number 1, and put it in the 8-bit adder. So this is yet to be this is this is after initialization. This has the value of 0. So 1 plus 0 becomes 1, and this is stored in the latch. This is stored in an accumulator. This is what we call an accumulator. This is an accumulator. So essentially, our first value becomes 1. Now, an accumulator uh, uh, is fed back our accumulator is fed back with this one, so this becomes 1. Now our counter moves up 1 to the next value, which is 2. So this becomes 2, and so this is our running total. This is our running total. What happens is 2 plus 1 becomes 3, and then it cycles back again. So that now our accumulator is having the value of 3, and this cycles back again. This is changed to 3, and then the next address in our counter becomes A3, which has the value of 3. So this becomes 3. So 3 plus 3 equals to 6, and then we have the value of 6 here, and then this becomes a running total of 6. Now, since our A4 is not defined, it has a default value of 0. So 0. So change this to 0. 0 plus 6 is still 6, and this stored here. This is 6. So finally, we have a final accumulated value of 6, which is 1 plus 2 plus 3 equals to 6. All right. So this is an automated adding machine. Again, notice that after our initial entry and with our input device, which is the control panel, we had our hands off, and we let the computer do automatically do the computation. Okay, so we have to mention that this is not yet a complete computer. Rather, it's just an automated adding machine where one can input the desired set of numbers to be totaled. A complete computer remains to be a machine which one can configure via a set of instructions in memory. We can configure the set of instructions that we need to do. Let's say we need to do an addition of a summation of a set of numbers, and then the difference of a set of numbers, and then we can load them back into memory. So let's say that we want a machine that does both addition and subtraction for multiple sets of numbers, and is able to store the final accumulated value into an address into the RAM. Okay, so we'll discuss this on the following video. Thank you for listening.